Hi everyone. Today we're going to be starting the topic called polynomials. Now, I hope some of you have heard of this topic before, and I'm going to start with the topic, the definition of a polynomial. So some basic terms, key terms, and some key definitions that you must know to answer some questions. Now I'm going to start with what a polynomial is. A polynomial is an expression of the form, and I'm going to give you this big expression here. I know it looks pretty big, but I'll show you a little bit by bit, so it's actually a lot more simple than you see. I'm going to denote it as px, and it might not be always px, it could be fx or gx or hx, depending on what the question is. Now let's start by concentrating on the a's that I have here. Now I've labeled it as a0, a1, a2, a3, n minus 1, n minus 2, n minus 1, and then n. Okay, now as you can see here, I'm going to let all these a's coefficients, the coefficients that are the numbers in front of the pronumeral. In this case, x is the pronumeral, isn't it? Now n must be a whole number because n is like a labeling, like the nth term, isn't it? So first term, second term, third term. So that's what I have there. Now these coefficients can pretty much be anything, doesn't have to be a whole number. It could be decimals, fractions, positive or negative. Now let's concentrate on the x's now, which are the pronumerals that I have. The smallest possible power of that x is 0. So for a polynomial, the smallest power is 0. The smallest possible power is 0. Okay, so see how a to the power a0 is a constant term because it doesn't have any x following. But that's because x has a power of 0. And we all know that x to the power of 0 is 1, isn't it? So when I multiply 1 to a number, it's just a constant number, isn't it? So a polynomial can have a constant number and then it goes increasing. So this is x to the power of 1, x to the power of 2, and etc, etc. Now the key thing for all polynomials is that the powers must be whole numbers, positive whole numbers. So it can't be negative, it can't be fractions, and it can't be decimals. And that's the key thing that you're going to look at in a polynomial to determine if it's a polynomial or not. Okay, so concentrate on the powers. Now, I'm going to give you a quick example of what a polynomial is, because by the look of this big expression, it's still a bit confusing, isn't it? So I'm going to start by calling it px as well. And I'm just going to think of this from the top of my head. I'm going to label it as 3x4 minus 2x3 plus, I don't know, half x squared minus 0.2x, and then plus some constant number 6. Okay, so if you can have a look here, it's pretty much the exact same thing as what I've explained above. It's got a constant term because this constant term has x to the power of 0 following, and x to the power of 0 is just 1. That's why this is constant. And then see how it goes, 1, 2, 3, 4. So the powers are clearly positive and they are clearly whole numbers. It doesn't really matter about what the coefficients are. As I said, the coefficients can be positive, negative, fractional, decimal, but the powers must be positive whole. That's what I'm keep going to be stressing to you guys. All right. Now I'm going to explain to you just a few more definitions, some key terms, and then we'll go to the questions. Now you got to really get along with these terms. They are the most frequently used terms that I'm going to be using throughout this chapter. Now, in polynomials, we often concentrate on the highest power of a polynomial, of that expression. Can you see that the highest power that we have in this example is 4? And we have a specific name for that power. We call it the degree. Can you? Okay. So when I mean degree, the highest power of the polynomial. Now the term that has that highest power, the term that has the degree, which is this term here, isn't it? That one, we call it the leading term. Leading term. And the coefficient of that term, in this case, which is 3, that one we call it the leading coefficient. It's pretty simple, isn't it? Coefficient. Get it? Pretty straightforward, I think. And then this is the constant term. One other thing you got to know is the term monic. Monic. A monic polynomial is where the leading coefficient is 1. But can you see that the leading coefficient here is clearly not 1, it's 3, so we can't call this a monic polynomial. This one is not a monic polynomial, so big cross through that. Okay, so just some key terms, not too many, so it's not going to be that hard. Just remember them as we go, if you haven't already remembered, if you tend to forget. So rub all this off, and let's try the questions together. So you guys are going to be helping me. Let's start with question 1. Determine whether each of them is a polynomial, and by them, I'm going to give you a bunch of expressions, like this one. And so there's A all the way to I, and you're going to help me determine if this expression is a polynomial or not. Now remember in the first section I told you that a polynomial, you must concentrate on the power. If the power is a whole number and it's positive, then it's pretty much a polynomial. So have a look at the first one. It's x minus 1. It's a very, very simple expression, and the power of x is 1. X is just x to the power of 1, isn't it? And 1 is clearly positive and whole, so we can say definitely it is a polynomial. That's all you need to really say. Now in B, have a look at all the powers of x. We've got a 2 and we've got a 1. They're all positive and whole, so yes, it is a polynomial. Now C, I hope everyone can tell me that this is not a polynomial, because have a look at the power. One of the power is 0.2. 0.2 is obviously not a whole number, it's a decimal. We can't have decimal as a power, so this one's not a polynomial. Now D, what do you guys think about this one? Square root of x. Can everyone tell me what square root of x is in a index form? Square root of x, we should all know that it's power of a half. And half again is not a whole number, so that one is also not a polynomial. Okay, very, very simple. E, have a look at this one is a positive one, but this one is a negative one. But negative one is not a decimal or a fraction, but did I say we can have negative numbers as a powers? No, it must be positive and it must be a whole number, so a negative power is not acceptable. So we say this one is not a polynomial. Now, we have a constant number this time. It's just a simple constant number, 12. What do you guys think? What do you guys think? Is it a polynomial or not? For those of you who said yes, it is a polynomial, well done, it is a polynomial, because although it's just a constant number, the reason why it's a constant number is because the x that follows has a power of 0. And we all know that x to the power of 0 is 1. So 1 times 12 just becomes 12. That's why it's a constant number. Now, hopefully you do remember that the smallest possible number that the smallest possible power that a polynomial can have is 0. So this one, if it's just a constant number, it's also a polynomial. Okay? Now G, it's in a factorized form, but that one, if it's expanded, it's pretty much x cubed minus x squared, isn't it? And you can clearly see that the powers are positive and whole, so yes, it is a polynomial. Now, H, again, the only x we have has a power of 4, which is positive and whole, so yes, it is a polynomial. And I, x has a power of 5, which is positive and whole, so yes, it is a polynomial. So we can go faster and faster now. And this 0.5, that's just a constant number. That's one of the coefficients. So it doesn't really matter if it's a decimal or a fraction. Okay? That's all you need to know. So as I keep mentioning, concentrate on the powers. So let's move on now. Let's look at question 2. Determine whether each of them is a monic polynomial. Now, does anyone remember what I said a monic polynomial is? I did go through it pretty quickly, but does anyone remember what a monic means? Monic is when the leading coefficient is 1. So a leading coefficient is the coefficient of the term that has the highest power, that has the degree, wasn't it? So if it's not 1, we can't call it a monic polynomial. Now, if you're still confused, don't worry, I'll just show you when I get to the questions. I'm going to show you a bunch of expressions again, A all the way to I, and we're going to determine if it's a monic polynomial or not a monic polynomial. So start with A. See, well, the only x we have is this one here. We don't have any others. So this one is the leading term, which has x to the power of 1. What's the coefficient of that x? It's clearly 1. This x is 1x. 1 is the coefficient of that expression, therefore it is a monic polynomial. That's what I mean by monic. Now have a look at B. What is the degree here first of all, guys? The degree is 2 because that's the highest possible power that we have in this expression. So x squared here is the leading term. But what's the leading coefficient? You can see that x squared is pretty much just 1x squared, isn't it? So yes, this time again, it's a monic polynomial. Okay, it's as simple as that. So you guys should be able to just do this in a few seconds. So in C, see how we have 3x? Well, the only x we have is this one. So what's the coefficient of that? It's 3. It's not 1. So we can't say it's a monic. It's not a monic polynomial. D, again, this is the only x we have, so that is the leading term. But what's the coefficient? The coefficient is -1, isn't it? So this one is not a monic polynomial. We can't have -1. To be a monic polynomial, it must be +1. So that's why this is not a monic polynomial. E, the highest power, the degree, what's that? It's 4, isn't it? And you can see that the coefficient of that term is 3, so it's not a monic polynomial. It can't be anything but 1 to be monic, is it? Now F, the leading term is x cubed because 3 is the highest possible power we have. And the coefficient of that is 1. So yes, it is monic. Okay? Now G, again, x squared is the only polynomial we have, so that's pretty much the leading term. And you can clearly see that the leading coefficient, the coefficient in front of x squared, is 1. So it is a monic polynomial. So you guys can pretty much do the rest for me. H, see x4 is 4 is the highest power, so 4 is the degree. And the coefficient is 0.1. It's not 1, so we can't say it's a monic polynomial. And the last one, what do you guys think? Is it monic or not? For those of you who said yes, bad. It's -1, isn't it? It's not +1. I told you it must be +1 to be monic. The number in front, the coefficient, is -1, so it's not a monic polynomial. Okay, really, really simple, isn't it? So that's pretty much it for this question on monic polynomials. Question 3. Find A, B, and C if we're given this particular equation. Now, I know a lot of people just tend to start by moving something onto one side and trying to gather the like terms, but we can't really do that. I don't think that's going to really help because we've got polynomials as our coefficients. So what I'm going to do is try the comparison method. So by comparison method, I compare the left-hand side with the right-hand side. Okay, now have a look, guys. Both sides of this equation have something in common. It's got x squared, and then it's got the x's, and then it's got some constant numbers, isn't it? So it's in that particular order, x squared, x, and then a constant. So because those are common, the coefficients of those respective terms must be the same as well. So see here, because the x squares are the same, the coefficients of that x squared must also be the same. So I'm pretty sure that A is 2. Let's do the same thing. Similarly, for the coefficients of x, because x is the same, the coefficients must also be equal. So B, the coefficient of x, must be equal to -1, which is the coefficient of x on this side. So I'm pretty sure B would be -1, and then the constants must be the same, so C is 3. So A must be respective to this one, so A is 2. As I said, B, I'll rub this off because I think it's bothering you maybe. The coefficients of x must be equal, so B is -1, and the constants must be equal, so C is 3. So this is a really, really simple question. Okay, so don't bother trying to solve those two equations together. Trying to do the comparison method. Okay, it's so much easier. Question 4. Okay, again, it's the exact same question. Find ABC. Now, this time, again, compare the left-hand side and the right-hand side, guys. But you can see it's a little bit different. Well, it's good that we have x squared, and it's good that we have the x, but we don't have a constant number here. It's not really the case that we don't have a constant number. This side is empty because the constant term is pretty much just 0. It's +0, okay? So you can compare the left-hand side with the right-hand side according to their terms. So x squares, that's what I mean. So x squares are the same, so the coefficients of those x squares must also be the same. So A must equal to 3. And bx and x, they both have x, so their coefficients must also be equal. So B equals to 1 because this is 1x. And as I said, this constant is plus 0, but we don't usually write plus 0, do we? So the constant here must be equal to 0, so therefore that's why we let c equals to 0, and that's pretty much it. Again, it's the same kind of thing as what we did in the previous question. Question 5, again the same thing, a, b, c. Now this time the right hand side is in a factorized form, so we'll have to expand that out, won't we? So I'm going to start by expanding it out, this side, and pretty sure everyone can expand that. I'm not going to go through the details of expansions, but that's pretty much what I did. That expanded to that, and now that we've expanded it, you can again see that we have x squared and x, and then some constant numbers. So left hand side and right hand side are in the same kind of form. So now again we can compare both sides. So let's start by comparing the x squares. Because x squared and x squared is common on both equations, both sides of the equations, the coefficients must be equal. So a must equal to 4. Similarly for x, the coefficients must be equal as well. So b is minus 4, and the constants must be equal. So c equals to 1. That's all. Okay, make sure it's all expanded so you can compare it nice and clearly. Question 6. Let's give it another shot. I think you guys can even try this on your own. Again, it's not expanded, so it's a good idea to expand and simplify the right hand side. So that's what I'm going to do. I've just expanded out this bracket here so it becomes x squared plus x, and then we can gather the like terms, can't we? Which is 2x. So now again, x squares are common, x is common, constant at the end. So it's in the same form. Now we can compare. So let's compare the x squares. The coefficient of x squared is 1. A must equal to 1, yeah? Same for x. The coefficients must be equal, so b equals to 2, and the constants must be equal, so c is negative 1. Very, very simple. Hopefully if you did that on your own, you got it all correct. Question 7. Okay, now they're asking for a particular term, particular definition, which is called the degree. Does everyone remember what the degree is? I did mention this quite a few times. We want to find the degree of this expression. And remember guys, degree is the highest power in a particular expression or a polynomial. So in this polynomial, guys, what is the degree? What is the highest power? You can clearly see that 2 is the highest power because this has a power of 1. It's less than 2. So the degree is 2. Simple question. And 8, again the degree is 5, which is the highest power in this particular polynomial, because 4 and this is power of 1. It's all less than 5. So 5 is the highest, 5 is the degree. There we go. Okay, so that ends and that concludes the definition of a polynomial.